at the stars, look how they shine for you, and everything you do. Yeah, they were all yellow.
Let's go ahead and get started with video number 14. Before we go into explaining the topic of this video, which is scale factor, let's do a quick recap on what a dilation is. A dilation is a transformation that changes the size of a figure without changing the shape. As illustrated in the picture above, a dilation either reduces a figure or enlarges a figure. An example of a dilation would be your pupil. Your pupil dilates according to the amount of light that hits the eye. A dilation has a scale factor, which determines the size of the image. Go ahead and go over to the vocab section of your geo book to the next available spot. Entitle it Scale Factor. The scale factor by definition is the ratio of the lengths of corresponding sides in the image and the pre-image. Ratio is another word for fraction, and corresponding sides is just matching sides. Let's go ahead and take a look at the example. To start solving for the scale factor, we're going to use this setup for our fraction. We're going to have new over old. So from left to right, I have my original figure, which is this triangle ABC. This is my pre-image, or for our purposes, in parentheses, the old. And it was dilated to the image shown on the right, which is A prime, B prime, C prime, which is the new in parentheses. So to find the scale factor, we're going to set up a ratio where we're going to have the new and over the old based on corresponding sides. Okay, let's look at our fractions. So first we have to set up by placing new over the old. My corresponding sides, I'm going to start with side length A prime, B prime. A prime, B prime corresponds to AB. So it's going to be new over the old. I have 4 over 8. 4 over 8. For my next side, I have B prime, C prime. B prime, C prime is 2 in length, and that corresponds to BC, which is 4 in length. I have 2 over 4. And lastly, my third side, so it's always new over old, I have A prime, C prime, which is 3 in length, and that corresponds to or matches to the side AC, which is 6, so 3 over 6. And these three fractions reduce to 1/2. So the scale factor is 1 over 2 or 1/2, or you can place it in this notation, which reads as 1 to 2. In sum, the scale factor is the number we multiply the side lengths of the pre-image to get the new side lengths for the image. So 8 times 1/2. 8 times 1/2 gives me 4. My next corresponding side, I have 4 times 1/2 gives me 2. And lastly, 6 times 1/2 gives me 3. Okay, let's go ahead and move forward to the notes section of the GeoBook. Go ahead and open to the next available page. Entitle it Scale Factor. Copy the question and copy the diagram. For question 1, we have that square A is a dilation of square B. What is the scale factor? Okay, to begin solving for the scale factor, first we're going to note that square A is the image, so this is the result of the dilation. And square B is the pre-image. This is my original or the old. So I have old and the new. So from old to new, this dilation is an enlargement. So the figure got bigger. From the notes, if a dilation is an enlargement, the scale factor is greater than 1. Since we are dealing with squares and all the sides of a square are equal, we only have to set up one ratio or one fraction to solve for the scale factor. So by the rule, I have that scale factor is equal to new over old. So my new, in this case, is on square A, that side length. So that goes first. That goes over in the numerator. I'm going to have 35 over the old. The old is from the pre-image, which is 28. So 35 over 28 is the scale factor. And I can reduce 35 over 28. So the number that divides evenly into both top and bottom number is 7. Okay, I'm going to go ahead and reduce the fraction. So I have 35 over 28. And 7 divides into both numbers evenly. So I'm going to have 5 over 4. Or we can also write it as 5 to 4 for the scale factor. Moving on to question 2. Go ahead and copy the question and the diagram. For question 2, we have, what is the scale factor of a dilation? Let's go ahead and start by identifying the pre-image and the image. The pre-image is here, and I know it is this rectangle because I just have the capital letters for the notation. And I know that this rectangle here is the image since I have the capital letters with the prime notation. So this one is the result of the dilation. So from here to here, we know that an enlargement happened. The figure got bigger. Let's go ahead and label the new and the old. So the pre-image is the old, and the image is the new. We need to find the lengths of corresponding sides in order to set up the fractions to solve for the scale factor. Okay, let's go ahead and take a look at the lengths of the rectangles. I'm going to start with the pre-image, which is the old. To get the length, I'm literally going to count the units across. I don't have to do the distance formula since it's a horizontal line. So I have 1, 2, 3 units. This side length is 3. For the new, the length would be, so let's go ahead and count the units again. 1, 2, 3, 4, 5, 6, 7, 8, 9. That side length is 9. We're going to do the same for the height of the rectangles. So we're counting the units across. And again, I could count the units across since it is a vertical line in this case. So I have 1, 2 units for the height. And on this side, I have 1, 2, 3, 4, 5, 6. To set up our fractions and find the scale factor, again, it is new over old. So let's look at the ratio or the fraction for the length of the rectangles. So we're going from new to old. From new to old, which is 9 over 3. I have 9 over 3, which reduces to 3. For the height of the rectangles, I'm going again from new to old. I have 6 over 2. 6 over 2 reduces to 3. So the scale factor is 3, or it can also be stated as 3 to 1. So again, the scale factor is a number by which the side lengths get multiplied by to get the side lengths of the image. So I have 3 times 3 gives me 9. 2 times 3 gives me 6. Go ahead and copy the question and the diagram. For question 3, we have determine the scale factor of the dilation of the triangles. And you're given the following information. You have that the side length for the side OA is 5, and the side length for OA prime is 10. So to set up your scale factor, again, it is the new over the old. So my new is the result of the dilation, which in that case is the side length OA prime, which is 10. So it's going to be 10 over the old, which is the original, the pre-image. So 10 over 5, and that fraction reduces to 2. So the scale factor in this case is 2, or it can be written as 2 to 1.